Hi folks, thanks to be here for this talk about Opentelemetry tracing. I'm Nicolas Fränkel. I've held multiple positions on projects during my career, developer, team lead, architect, and a couple of years ago I've switched and now I'm a developer advocate. So like you can see, I'm experienced, and at the time when I started to work there was no such thing as observability. We were talking about monitoring, and monitoring was very simple. It was a bunch of people looking at a huge wall screen, or when your budget was smaller, a small wall screen, and when something happened, then they would start typing on a keyboard. That was basically the peak of alerting at the time. The problem is that our systems are becoming more and more distributed. And I mean, even if you don't do microservices, and probably you shouldn't, there is no denying that the systems that we're using are more complex and are more distributed. And so monitoring, just looking at the screen, is not enough. That's why we came up with this new idea of observability. And here I let you read the Wikipedia definition. And in general, I like a lot Wikipedia, so I use a lot of definition by Wikipedia. And here it's interesting that the definition mentions logging and tracing. However, the definition of observability is based on three different pillars. Metrics first, logging and tracing. This talk will mostly focus on tracing, but I will mention a bit metrics and a bit more logging, because I believe you can't do one without doing the other. So metrics is what we have been doing for ages. Actually, when I was mentioning people looking at the screen, it was exactly that. We were looking at dashboard, at metrics. However, we were looking at very low-level metrics, such as CPU, memory, and stuff like that. So every organization knows how to do metrics. I mean, the technology is there. I would advise you, if you are doing metrics, and you should, to have higher level metrics that are closer to the business, that speak to the business. Because if you tell them, hey, look, we have, let's say, 85% of memory consumption, they might not be that interested. But telling them, hey, look, we have 10% more of orders than last week, then they might be a bit more interested. And you might get budget for that. Logging is a bit more complex than metrics. The first thing is, what do you log? When I was a young engineer, I thought, wow, logging is super boring. And we need to tell developers about it. What if we could just automatically log all interesting stuff? And by interesting, I meant perhaps we can log all input parameters of a function and log the return parameter. And I thought that was a really good idea. And so I was working on the JVM at the time. I created a very simple Java agent that did that, so that the developers didn't need to do anything, that the agent would do that itself. The problem is that I forgot that sometimes some input parameters are not meant to be logged, such as passwords, for example. So I forgot this idea afterwards, and that's the problem. You can't have something that is automated in this regard. You need to take really care of having good manual logs with the right level of logging. So please, when you do code reviews, check that they are logs and check that they are relevant and that will actually be helpful when something happens. The logging format is also interesting. Historically, when something went wrong, what we did is we logged into the machine and we read the log file and we tried to find what happened, looking at the stack trace, for example, or even, as I mentioned, the regular log message. The problem nowadays is, which machine do you want to log into? Because you don't know the machine that created the log. You don't know where the error comes from. Even worse, the machine might be long gone because the machine was a container and the container has been removed by, I don't know, Kubernetes, for example. So there is no way to actually read the log file that exists. So in general, in order to cope with that, you would have a centralized logging system that actually collects all the logs. And in this centralized logging system, the log is actually parsed. When it receives the log, it parses it to extract some interesting metadata, such as the level, the timestamp, and stuff like that. Henceforth, this parsing phase can actually break the thing. It's more time-consuming, it's more fragile, and it's more CPU expensive. Basically, there is no real benefit from having a human readable log anymore. The idea is just write your log using JSON format with all the metadata that you want, and then parsing becomes very, very easy. That's something to consider for you. Likewise, when I started my career, I was told never ever to log on the console because it's very, very bad. Instead, I should write to log files because then they could be rotated and whatever. Nowadays, where do we log because we use containers? Most probably on the console. It changes all the time. Be careful about this. I mentioned the logs aggregation, and also a couple of other things that you need to think about is whether to actually push the log to the centralized logging system or for the centralized logging system to scrape the log or to have like more complex architectures with agents and stuff. I mentioned the structure versus unstructured. You should really have JSON or however the format you want, but probably JSON to have structures so that the parsing is very easy. Then you need to think about storing the log. How long will you store it? Is it like, will you need it for auditing purposes, or will you like rely on something more durable, this kind of stuff? And then searching and displaying. Here are a couple of logging systems that you might be familiar with. I personally know the Elastic Stack more than others, but I mean, all of them are very, very nice. And now comes the time for the third pillar, tracing. So again, here is a Wikipedia definition, which this one is actually, I really, really don't like it. So I came up with my own that was probably inspired by others. And the idea is it helps with following a business request across multiple components in your information system. And this is a new idea. This is actually something we had before. We had pioneers such as Zipkin, Jaeger, and OpenTracing. The problem is all of them had their own proprietary way of doing things. And basically, if you choose one of them, you were limited by the tools, by the libraries, by the frameworks that supported them. If you choose Jaeger, for example, you were limited to only tools, libraries, frameworks that supported Jaeger, and that's not great. So when such situation happens, probably what we need is a standard. And by standard, I mean not like the XKCD comic saying, oh, we've got 14 standards, we will create one standard to unite them all, and then you've got 15 standards, I mean a real standard. In that case, we need a strong governing body, and it's the W3C. And the W3C came with a trace context specification. It's not really very hard to read. It's like 15 pages. And it comes up with the idea of the HTTP header that will propagate certain information from HTTP request to another HTTP request in your information system. It defines two base concepts that are quite straightforward. The trace, and basically the trace is a single business request across all your components, and the span. And the span is something that happens in one of the components. And a span is related to a trace. and spans are related to one another by a child-parent relationship. So here in a graphical point of view, you can see that I have a single trace, and the trace runs across three components, X, Y, and Z. And you see the spans. X is the first span, it has no parents. And then Y and Z, they have X as a parent, and they have no children. So you could potentially implement that all by yourself, but it would be much, much nicer if you had something that implemented it for you. And that is one of the ideas behind Opentelemetry. Opentelemetry is not limited to distributed tracing. It does the metrics and the logs as well, but it also implements the W3C trace context. Interestingly enough, it's a merger of Open Tracing and Open Census. So it's one of the few successful merge in the open source. I really like it. And nowadays it's very, very popular. You can think about Opentelemetry like the black hole of tracing and logging and metrics in the industry nowadays. And it works across many, many different stacks. The idea is it doesn't define a lot. It provides you tools and library and stuff, and it defines two important things: the Opentelemetry protocol and the Opentelemetry format. So how do you connect to the Opentelemetry collector, and in which format do the apps or the tools need to send the data? It provides you with one Opentelemetry collector, but it's not part of like the requirements. Actually, you can define your own Opentelemetry collector as long as it's able to receive Opentelemetry in the correct format, Opentelemetry data in the correct format, then it will be perfectly fine. And this is actually what happens that Jaeger and Zipkin, our like legacy distributed tracing providers, are compatible with Opentelemetry. Basically, if you have any one of them already inside your information system, then you can like activate them, enable them, the Opentelemetry port, start sending them Opentelemetry data in the Opentelemetry format, and nothing will change. But what you will enable is now you will be free to use anything that is Opentelemetry compatible. And as I mentioned, since Opentelemetry spans much, much more than either Jaeger or Zipkin, then you will have more freedom choosing your libraries or frameworks or whatever. Now, how do you do it? How do you send Opentelemetry data? Well, there are two different ways to do that from the point of view of a developer. The first question is, on which stack are you working? For example, do you have a runtime? That's the most important question, is do you have a runtime? If you have a runtime, like you are working with Kotlin or Scala or Java, you have the JVM as a runtime, then there is something called auto-instrumentation, meaning that the developers, they don't know nothing about Opentelemetry, they are not even aware that something will be instrumented afterwards. At runtime, there is something on the JVM, it would be an agent, for example, that will instrument the code and send the Opentelemetry data to the Opentelemetry collector. Another way is you don't have a runtime, or the default auto-instrumentation is not good enough for you, you want more detail, you want to tweak some stuff, then at this point, you come to the point where you actually need to have a dependency, a library, and then have the developers actually create the spans and make the calls explicitly. I would really, really encourage you to use auto-instrumentation first if you can, again, if you have a runtime, because it means that there is no coupling, you don't bother the developers, there is no hurdle, it's a low-hanging fruit. And you can even do it as an experiment, so you don't need to tell anybody. You set up the Opentelemetry collector in a dark corner of your information system. You when you run, you add the agent or whatever path for the agent in your stack. Then you say Opentelemetry data. And when there is a bug, then you can use it to debug. And then afterwards, you can go to your manager and tell them, look, this is how we solve the stuff. Now, perhaps we can do it in a more professional way. Please give us budget. That's what I would advise you to do. I've talked a lot. Now it's time for a demo. And I like demos, but most of the demo I've seen over like the talks is just like hello world. So here I would like to propose you something a bit more advanced than hello world. It's still a demo. I can have a full-fledged project, but at least I want to show you like a real distributed system. Here it is. So the context is the homepage of e-commerce shop. So I want to have some products and I want to know their price and if they are available in different warehouses. So the first request goes to products and it goes to the API gateway because I need to protect my APIs, perhaps do some rate limiting as well or whatever. Then it forwards it to the catalog. The catalog is the front component. It's a Kotlin Spring Boot application, and it requests the stocks to an inventory component, which is with Rust and Axon. And then the inventory requests multiple warehouses. Each of the warehouse is developed in a specific technology. In front, I have another API gateway, which is the internal one just for the warehouses. So I have one that is still in Kotlin and Spring Boot, but instead of running on the JVM, I'm using GraalVM to make a native executable out of it. And because I'm using GraalVM, I can't use a Java agent. Then I have one that is in Go with Gin Tonic. Then I have one in Ruby with Sinatra. For the price, I'm asking a Python Flask application. And for whatever reason, it's very, like the performance is poor, so I want to cache the prices when I can through Redis. And I have something a bit extra. I mentioned that everything works as HTTP headers because of the trace context specification, and Opentelemetry works very well with that. It supports it. And I've done this talk multiple times. A lot of people were asking, what about asynchronous communication? What if there is no HTTP? What if I put some data in a MQ queue or in a Kafka queue? How do I get the Opentelemetry to work? So I have added it. I have added a component that will actually read the MQTT queue, and the catalog will publish some data into it. And I can show you that, I will show you how it works across this asynchronous message. So here is the whole project. I'm using Docker Compose, and I will start it, and then I can describe everything. So Docker Compose up. And here is everything. So first, I'm using Jaeger as my Opentelemetry collector. It's not because I'm a Jaeger expert, it's just that because it's super easy to configure it, and there is one single image, and that makes my life so much easier. Here you can see I have an API gateway. I'm using Apache API 6. Then I have my catalog. I mentioned it's a Spring Boot Kotlin application. Then I have the pricing, which is a Python Flask application. The inventory is in Rust with Axon. Another API gateway just for the warehouses. The warehouse in the US is Go and GoGin. In the EU, I'm also using Kotlin, but I will use GraalVM. I will show you it slightly different. Then I have the warehouse Japan, which is Ruby and Sinatra. I store all the data of products and pricing and warehouses in different Postgres schemas on one single instance. It's a demo, and then I have everything, not everything. I have the caching of the price in Redis, because imagine that the pricing, the Python Flask application is not very responsive or is very far away, or I don't know. So I want to cache the pricing. I've started it. So now I can do a curl. So I will curl local hosts 9080/products/1. Okay, the JSON is not important, and let's see how it looks on the Jaeger side. So here is my Jaeger. I can find the traces, and here I have all the traces. One, because I spent one request. So remember, one trace is one business request. And if I click on it, amazingly, I already have everything that is in front of my eyes. So I got all the components that I'm using, and in some components I have multiple spans because reasons, and you can see the flow from the API gateway to the catalog, from the catalog to the inventory, or from the catalog to another API gateway, and then to the pricing. And even if you are not a DevOps person, then even if you are an architect, it can be super, super interesting, because here you can see that the catalog is calling the inventory directly, but the catalog is calling the pricing through the Apache API 6 gateway. So it might be on purpose, but in general, either you are using an API gateway for security purposes, or for tracing purposes, or for whatever reason, or you are using nothing because for performance reason. But here it might be suspicious that in one case you are using a direct call, and here not. And you see that the catalog calls the API 6 front, so it calls back the API gateway which forwards the call. Whereas here we see the inventory is calling the second API gateway, the one that we want to use actually for our warehouses. I mentioned that you actually would prefer to use auto-instrumentation when you can. At conferences, in general, I ask people what stack they are most interested in. There are many, many stacks. I can't describe them all in the time that I have. But here, since I don't do it live, I will use the one that I will describe, the one with which I'm the most familiar, which basically will be like the catalog, which is Spring Boot Kotlin, the warehouse EU, which is Spring Boot and GraalVM, and Python. Everything is on the GitHub repo. In the last slide of this talk, you will find the link. So don't worry if it's not the stack you are mostly interested in. You can find all references and check the code. Let's start. So here in the catalog, I mentioned this is auto-instrumented. So here you will find nothing, and you can see that there I didn't lie to it, it's a Kotlin app. You will find nothing that is actually Opentelemetry related. And even though the developers don't know nothing about Opentelemetry, in the Jaeger you can see the catalog appearing. So why? That normally would be a runtime configuration, but here I'm using images, so I made it like a build time concern. So this is my Docker file, how to build my catalog. This is a multi-stage Docker file. It has two stages because it's a like Java app, or here a Kotlin app, so a JVM app. The first one we will actually compile to bytecode. So this is, I require a GDK. And the second part will be a GRE because I don't want to have any compiler in my image. I will avoid that at all costs because it's just more attack surface. So I am first creating the catalog.jar, and then I copy it in my final image, and here is where the magic happens. I'm actually adding the latest Java agent version from Opentelemetry, and when I run it with the agent. So if you are not familiar with a Java agent, basically an agent allows you to change the executed bytecode. And here what the agent does is when it receives an HTTP request, regardless of the technology, it knows a lot of different technologies, then it will get the HTTP header. So inside the HTTP header, you have a trace ID, the span ID, and perhaps some additional flags. And then it will record them, put them in some context, and it will create the spans. And when it sends a request to another component, then it will send the HTTP header along. And so this is how the context is propagated from component to component. Works pretty well. On the opposite side, without the catalog, I mentioned there is this like GraalVM stuff, which is the EU one. And here we don't have the benefit of the agent. And the problem is, well, without an agent, we can't use this magic. So in this case, we need somehow to get the Opentelemetry to work. So we are using the very specific library for Spring Boot, which is micrometer tracing, and the bridge to hotel and the exporter to Opentelemetry. The reason for this is by default, this is another protocol. Micrometer tracing is by default using another protocol. So we need to tell it, no, use this one. However, the benefit still is that the code itself, the warehouse application, there is nothing Opentelemetry related. Like everything happens because in this case, the Opentelemetry code will be compiled to native code and it's able to intercept the gate mapping and the REST controller stuff. So instead of being done through the agent at runtime, the behavior is baked into the native code. So this is the Docker file for the image. I also have two stages because the first stage is I will be compiling, but instead of compiling to bytecode, I will compile to a native executable. And the second stage is I will just add it to my regular, like the smallest container possible, which is BusyBox, and run the native executable. But in both cases, the developers, they don't need to know anything about Opentelemetry. You just do it so again, build time in one case, or the other time will be at runtime, but because we are using a container, it will be at build time as well. And Python is also using a runtime. So if we look at the TOML file, we see nothing, no dependency or no adherence to any Opentelemetry stuff. Likewise, the Docker file is where the magic is. So we install the Opentelemetry like manually during the creation of the image. Then we install all dependency. And here there is this very, very specific stuff. In the Opentelemetry distro, we have this command line called Opentelemetry Bootstrap. Basically what this does, it will sniff every dependency that we installed previously and check if there is a corresponding Opentelemetry library. So imagine we are using Flask. It will check, is there a Flask Opentelemetry dependency? If yes, install it as well. So whatever we are using, then it will check if there is a relevant Opentelemetry library and install it. For this reason, when we look at the pricing here, we can see that it sniffed something. Like when it does the connection to the database, it's able to know it. Why? Because the driver that we are using has an Opentelemetry dependency that it's able to sniff. And likewise for Flask, right? Nice. So we know now about auto instrumentation. And now imagine that we managed to solve a bug and we have some budget and we want to add additional trace spans or to tweak the existing spans. So I will add manual instrumentation, and depending on the stack, there might be some like changes. So I have stopped it, I start it again, and now I can curl again. I will wait until everything has started. Okay, I code again. And here, so I had 22 spans. I find the traces, I have 26, I have additional spans. I have manually added additional spans. So here, for example, let's check the JVM, the Kotlin running on the JVM. The Kotlin running on the JVM, I've added one additional dependency. And this dependency is this one, annotations. And with this annotation, what I can do is I can add stuff like this with span. So here I have added this annotation, meaning that this function is actually now instrumented. Likewise, this one. Likewise, this one. But here there is a tweak. Let's say that's the function name. I want to override it. Then I can add this like label. So instead of here, I should have something like product or products, probably because I'm asking for one product, it should be product. And instead of having fetch product detail in my Opentelemetry trace, I should have product handler fetch. Let's see. I have product, yes. And no, sorry, this one is product. This one is because I am instrumenting the driver, and this one is fetch. So I have everything. About fetch, there is something interesting that here I have something, I want to add additional metadata. For example, there is a bug and for whatever reason, I have a mismatch with the price. So I want to know that the product ID that I'm sending to the pricing is the same product ID that is requested by the catalog. So I want to have it in my metadata, in my span. So here I can add an additional parameter to my method and say it's a span attribute. I call it however I want, and then it will appear. So here, it appears here as product ID 1. And if I make another request, so I will have another trace, and I can find the trace, and here there should be a product ID 2. That's how it works. And now let's check on the Python side. So on the Python side, I have added manually the dependency, the distro, so that my Docker file is slightly different. I don't need to add the Opentelemetry during the build of the image, but now I can use in my code Opentelemetry. And here I don't use annotation, I use the API directly. So basically I will create a span where again I put the attribute of the product, and as the name I'm using it as a SQL stuff, which might not be such a good idea, but this gives you an idea on how you can use those labels. You put whatever you want. So here in the trace, my pricing, where is it? Is here. So I have this span, right? And I have the product ID 2. So if there is a bug, it's not because I'm passing the wrong product ID. There is no mismatch between the product ID on the catalog client side and the pricing server side. If I have a bug, I need to check elsewhere. That's good. Now we want to go the full stop, and I want to show you asynchronous messaging. How can we leverage Opentelemetry with asynchronous messaging? So I'm back on my Docker Compose. I added an additional component, the analytics components that depends on Mosquito. Mosquito is like a MQTT provider. And here I have this module, which is a Node.js TypeScript component. So the idea is that I have some dummy analytics. Every time the catalog I receive a request, I will send some data into the message queue, and the analytic components is subscribed to the message queue, we read it. And I want the trace to go through this message queue and up to the analytics. Two things. First, on the provider side, on the catalog side, and then on the subscriber side. So here on my Spring Boot application, I can't just say I'm using just annotation. I actually need to use the full-fledged API. That requires an additional dependency with Opentelemetry. And in the component side, here I have added the analytics. This is a filter if you are familiar, or even if you are not familiar with Spring Boot, I have this analytics filter. So every time I receive a request to either the product or products with an ID endpoint, the filter will kick in. I have initialized it. I don't want to bore you with the detail, but basically what it does is it will create a message holder where you will pass interesting stuff, suggest the span context. And so inside this filter, what I'm doing, I'm actually reconstructing a header, what would have been the HTTP header, but here I just reconstruct it as a simple string, right? And I'm using it as a metadata that I will send along the analytics message. There are basically two ways to do that. If your queue or Kafka or whatever is able to receive metadata, you can store it as a metadata. If not, you will just need to change the payload and to send it along with the payload. It depends on what you are doing. Here I'm using MQTT. I think it's v5, so it accepts metadata. I can send it the metadata. So I use it. I reconstruct the whole trace parent myself. And then I send it along with the payload, which is nice. So now the MQTT message goes into the message queue and it waits there to be used by something. This something is the analytics. So the analytics, I'm much less proficient in nodes than anything else, but basically is just initializing the client. And when something happens, when I receive a message on a specific topic, then I will get the data. But I don't get only the data. What I'm doing is I'm also reading the metadata. The metadata where there is a trace parent. And look, this is where the magic happens, because this component, this Node.js application, has a dependency on Opentelemetry, then I'm using the API to reconstruct the context from these trace parents. And because I have now an active context, I can say, okay, I can start a span, manually, from this active context. Might be a bit hard to understand, from the code, so let me show you with a curl command. So 2 is good. And here you can see this new component, analytics. And when I check it, you can see that here the analytics creates a span under the catalog. So it's part of the whole trace. It's part of the flow. It's able to say, okay, we are part of the same trace, which is really, really nice. This asynchronous stuff is very powerful. However, be careful. Imagine that the analytics component is down for some reason. I will stop it so you can see. Oops. And Docker compose stop analytics. I will send another request. And so here is my trace. So here, no analytics, of course, nothing happened, but the trace looks very nice. However, if we start the analytics component again, then it will catch up. I will start the analytics component again. It catches up. And if I refresh here, not here, if I refresh, yes, it was not too fast. So you can see that on one side we have milliseconds, long seconds, and again milliseconds with the analytics. So depending on what tool you are using to display the trace, you might want not to do that, or at least to have a tool that filters out this asynchronous stuff, because if everything happens, I don't know, in milliseconds, and the message is consumed 2 or 3 hours afterwards, then you can't see anything anymore, and actually the analytics creates trouble in your visualization, which might not be what you want. And so thanks a lot for your attention. You can find everything that you need in the GitHub link. Of course, you can still follow me on Twitter, or if you think it's dead, and I believe it's dead, on Mastodon or on Blue Sky. And I will be happy to answer some questions live. Thanks a lot for your attention, and I wish you a good day.